Today we are going to learn the last lesson of Unit 7, which is 7.55 Geometric Sequences. So remember in Unit 4 when we had lesson 4.55, and that was the lesson that was between 4.5 and 4.6, and it was on arithmetic sequences. So a sequence is just a pattern or a list of numbers that, and an arithmetic sequence is a list of numbers that follows a linear pattern where you add or subtract. But a geometric sequence is going to be a type of sequence where you multiply or divide, which follows the exponential pattern. So geometric sequence follows an exponential pattern, whereas an arithmetic sequence follows a linear pattern. Right, so today we're going to learn how to identify and write formulas of geometric sequences. So identify the next term in each sequence of numbers below, then describe the pattern. So here we have 1, 2, 4, 8. So the next number would be 16. And the pattern is you're multiplying by 2. How about instead of the pattern, let's just say what the factor is. So you're multiplying by 2. Here you have 2, 6, 18, 54. So you're multiplying by 3. What would be the next number? 54 times 3 would be 162. And then 16, 8, 4, 2. The next number would be 1 because you're multiplying by 1/2. And here you have -1, -4, -16, -64. It looks like we're multiplying by 4. Now be careful, we're not multiplying by -4. If we were multiplying by -4, then every other number would be negative. So it'd be like -1, +4, -16, +64, because when you multiply the negative by a negative, then you would get a positive for the next number. All right, so each sequence of numbers above is considered a geometric sequence because the pattern from one term to the next involves multiplication. And just a reminder that if you're dividing, instead of dividing, we ask ourselves, what are we multiplying? So if you're dividing by 2, you're multiplying by 1/2. If you're dividing by 10, you're multiplying by 1/10. It's just the reciprocal of that number. So if a pattern or sequence of numbers is geometric, that sequence can be written as an exponential function. To write the equation of a geometric sequence, we use this following formula. So g of n equals g of 1 times r to the n minus 1, where r is the common ratio. Okay, so instead of, remember how the arithmetic sequence was, we had the common difference. Now is the number that you would have to add or subtract to get to the next number. The common ratio is basically what your factor is. So sometimes your factor is a whole number, sometimes it's a fraction, and then g of 1 is the first term. The only thing that you really have to remember is this n minus 1. So instead of just x, it's n minus 1. And the reason is because when you work with arithmetic sequences, you don't start with 0, you start with 1. So you go 1, 2, 3, 4, 5, where for just a regular function, your first term is when x is equal to 0. That's like your y-intercept. So we have to subtract the exponent from 1 so that the first term is 1 and not 0, the y-intercept. All right, and then g of 1, that is like your first term. I guess it says that right there. So identify the common ratio. So just to reiterate, this is kind of like the function a times b to the x, where a is g of 1, b is r, and x is n minus 1. So identify the common ratio and then the first term for each sequence, then write the geometric sequence. So if g of 1 here is 1, the common ratio, we're multiplying by 3. So g of n would be 1 times 3 to the n minus 1. And that's it. Okay, g of 1 would be 24. We're multiplying by 1/2. So g of n would be 24 times 1/2 to the n minus 1. All right, number 3. Your first term is -4. The r value is 2. So g of n would be -4 times 2 to the n minus 1. And then number 4, g of 1 is -64. Looks like we're multiplying by 1/4, because remember, if we're dividing by 4, our numbers are getting smaller. This would be decay. So instead of dividing by 4, we multiply by 1/4. And then the function would be 64 times 1/4 to the n minus 1. Okay, so here's a couple different examples. We're going to use the formula to find the first 4 terms of the sequence and then check on your calculator. So we're going to solve this by hand, basically. So we'll do 4 times 3. So basically we're plugging in n equals 1, n equals 2, n equals 3, and n equals 4. It's supposed to be a 4. All right, so if n is 1, then you have 1 minus 1, which turns into 0. 3 times 0 is 1, so you just have 4. Here, 2 minus 1 is 1, so you have 3 to the first, which is 3. So then 4 times 3 is 12. Here, 3 minus 1 is 2, so you have 3 squared, which would be 9. And 4 times 9 is 36. And then here, 4 minus 1 gives you 3. 3 to the third is 27. And 4 times 27 is 108. All right, so this one, you don't need to do this each time, though, because I'm just showing you kind of the why. Why does this equation create the pattern that we are looking at? But really, all you need to do is identify the first term, which would be 4, and then multiply that by 3 until you get 4 terms. So 12, 36, 108. All right, here let's do it the short way. Okay, so the first term would be 1. The second term, we're multiplying 1 by 1/2, so that would be 1/2. And then if we multiplied 1/2 by 1/2, we would get 1/4. And if we multiplied 1/4 by 1/2, we would get 1/8. So that would be the first 4 terms for that equation. Okay, so that's the explicit rule. Now we're going to learn about the recursive rule. Remember how with the arithmetic sequences there were 2 different rules? So there we go. All right, so this is the recursive rule here. A recursive formula tells how the current term relates to the term before it. Therefore, the first term of the sequence will always be given, just so you know at least one term. And then we're just using f of n here, same thing as g of n. So find the first 4 terms of the sequence, then give the recursive equation. All right, so for here we have, remember it's always related to the term before. So remember how we had a sub n equals a sub n minus 1 plus d? So here we have, for the recursive rule, you have f of n equals r times f of n minus 1. So basically you take your previous term and multiply it by the factor. So here the factor would be 2. 2 times the previous term gives you the next term. And then the first term they said is 5. So how do they want us to fill in this table? Okay, so the first term is 5. And then we're going to take 5 and multiply it by 2. So you get 10. And then if you multiply 10 by 2, you get 20. If you multiply that by 2, you get 30. Okay, well, don't worry about the rest of the table. And then we're going to write the explicit rule. So the explicit rule would be the first term, which is 5, times your factor, which is 2, to the n minus 1. All right, so that's the explicit rule if this is the recursive rule. Okay, let's try another one. So here, our recursive rule is g of n equals 1/2 times g of n minus 1, and the first term is 4. So let's just fill out this part of the table. So we've got 4, and our factor r is 1/2. So we're going to multiply 1/2 to get to each term. So 4 times 1/2 is 2. 2 times 1/2 is 1. And 1 times 1/2 is 1/2. So g of n for the explicit rule is, what's the rule? G of n equals g of 1 times r to the n minus 1. So your first term, which is 4, times your ratio, which is 1/2, to the n minus 1. Okay, and one more. So here, the factor is 3. First term is -2. So we've got 3. We're going to multiply that by -2. So -6. -6 times 3. Wait a second. Oh, I know. Okay, this table is messed up. So the first term should be -2. So we're doing -2 times 3, which is -6. -6 times 3 is -18. -18 times 3 is -54. So then your explicit rule would be the first term, -2, times your ratio, which is 3, to the n minus 1. Okay, so that tells you how you can relate the recursive rule, or how you can use the recursive rule to figure out the explicit rule. Okay, and then here's just a couple more examples. So write the explicit formula for the geometric sequence. So for us, remember that the function f of n equals f of 1 times r to the n minus 1. So you've got your first term times the ratio to the n minus 1. So here we would have f of n equals, the first term is -3, and we're multiplying that by 3. Oh wait, no, sorry, we're multiplying by 5. So times 5 to the n minus 1. Here, this looks like it's going to be, and also this is growth. So because although your numbers are getting more negative, they're still getting bigger. Here our numbers are getting smaller, closer to 0, so this is decay. So here we would have f of n equals our first term 2, and then it looks like we're multiplying by 1/4 each time. So 1/4 to the n minus 1. All right, so make sure you've taken good notes over all of this so that you are prepared for Monday's assignment. And that is all for today. Hope you guys have a nice weekend.